All right, so now we're going to look at percent change. So again, you're going to be using the data table from page 1 of your notes. And what we're going to look at is in 1960 and 2010, what the levels are. My final level was 392. My initial level in 1960 was 319. I take that difference, I divide by the initial 319 equals percent over 100. When I cross multiply and solve, I'm going to get 22.9%, or if you wanted to round it to 23%, that's great. So that's how I'm doing percent change. Percent change is something that's often used. Realize you can actually get a percent change that is greater than 100%. And so you might see those, and don't be freaked out if you get something over 100%. Next, percent change from 1970 to 2000. So in 1970, it was 328, and in 2000, it was 372. So I'm going to take 372 minus 328. Big thing is people always forget which one to divide by. You always divide by the initial. Equals percent over 100. Remember, order of operations, I got to do that subtraction first. And in the end, I get 13.4% change. So this is how I'm going to work through these problems. It's the same exact process. 1990, my rate was 356. 2017, it is 409. So that difference, 409 minus 356, always divide by the initial, is percent over 100. Cross multiply and solve, and I get 14.9%. Last one on here that I'm going to do is I see 2010 to 2017. And as you maybe saw when we did the conversion factors before, this gave me the biggest conversion factor, or the biggest change per time. But here, when I do a percent change, this is 392. This is 409. So my difference, 409 minus 392, divide by the initial, is percent over 100. Cross multiply, and I get 4.3%. So this is mathematically how you do this. Realize people often pick the numerical analysis that best supports their argument. So if I wanted to freak you out about the change in CO2 levels, does 4.3% really freak you out? Probably not so much. But if you look at your answers above on the page from 4A and 4B, seeing that conversion factor, that change rate, and seeing in 2050 a rate of or a level of 489 parts per million of CO2, realizing that we're at about 410 or so in 2018, 2019, realizing that, then that starts freaking you out. So again, even though it's this exact same data, people often pick the numerical analysis tool that best supports their argument. This is how you do percent change, though.